number 6 is asking us, is acetic acid a weak or strong acid, and why? Okay. So this number 6 here. Yeah, this number 6, right? Yep. Number 6 is asking us, is acetic acid a weak acid or strong acid? So first, let's look at acetic acid. Is either strong or weak. They're asking why. So if we look at the chemical formula for acetic acid, this is the chemical formula. We have CH3 COOH, right? So basically with acetic acids or any basically carboxylic acids, there's a really good rule. And basically you can say that carboxylic acids, or most carboxylic acids, and actually a lot of them, carboxylic acids behave as weak acids. And the reason why is because we have an acetate ion and we have this H plus ion, right? So if I have acetic acid here, and I can draw out my kind of equilibrium here. So CH3COOH is going to react with water to form. Again, I have H3O plus because I know it's a weak acid here, but this here will form I have my acetate ion, so CH3COO minus here. And this here is I have a Ka specified for CH3COOH here, and I believe again it's like 1.8 times 10 to the negative 5, I want to say, or that's ethanoic acid. But acetic acid here would be, let's see, yeah, 1.8 times 10 to the negative 5 actually, which is what I said, right? Yeah. So, or 1.76 times 10 to the negative 5, 1.8 times 10 to the negative 5 here. And it's actually a very common acid that we use in organic chemistry. And basically, because Ka is less than 1 here, so it's actually going to be a weak acid, because Ka here is less than 1, therefore weak acid. It doesn't fully dissociate in water, right? And the difference between strong and weak acids is very simple. Strong acids fully dissociate in water. So strong acid would be something like an HCl, right? HCl, if I add water to it, it's going to fully dissociate. It won't go backwards. And I'll form my hydronium ion plus my Cl minus ion, right? This is not a reversible reaction here. Whereas this guy here is reversible depending on concentration, temperature, pressure, volume, all these things as well. So in this case, this here is going to be a weak acid. So acetic acid is my weak acid as defined by this. And why? Because my Ka is less than 1, carboxylic acids will also behave as weak acids, and because they don't fully dissociate in water. So that's the big giveaway here. So Ka is 1.8 times 10 to the negative 5, which means it does not fully dissociate in water here. And so this solution is, I believe it's correct here. Acetic acid, ethanoic acid, it's the same thing. That's good. And this is a weak acid, which they said before. And why? Did they say why? Let's see. I'm trying to scan this, and I don't think they said why here. So, this is our example. So I'm going to say solution here is correct. Acetic acid is a weak acid. And here's an explanation. I don't think they wrote an explanation here, but I'm going to say carboxylic acids. That says, or organic acids are commonly used as weak acids because they do not, they do not fully associate. This is a do not. I forgot a do not here. Do not fully dissociate in water. In water, strong acids dissociate fully. Cl, whereas acetic acid does not. And then you can write here CH3 COH plus H2O will be both reacts to form H3O plus CH3CO minus. So solution here is correct.